Okay, so let's have a look at example 32. It's a combination of what we did last lesson and the 4 new equations that we talked about this lesson. So we've got here, if cos of A is 12 on 13 and sine of B is 7 over 25, and we know that A is in quadrant 1 and B is in quadrant 2, what is the exact value of sine of A minus B? So it says here sine of A minus B, which means if we look at the formula, A minus B, we need to work out individually what sine A, cos A, and cos B, sine B are. So this is where we do what we did last time and use the Pythag identity, that sine squared plus cos squared equals to 1. So using sine squared A plus cos squared A equals to 1, we have that sine squared A, well, cos of A is 12 on 3, so cos squared A is 12 on 3 all squared equals to 1. So in other words, rearranging sine squared A is 25 over 169 if you subtract square and then subtract from 1. Oops, 169. And then the opposite of squaring is square rooting, so therefore sine of A is plus or minus the square root of 25, which is 5, and the square root of 169, which is 13. We have 2 possible answers, but because our A angle is limited into quadrant 1, and in quadrant 1 sine is positive, so we can take the positive value. So since our A value is in quadrant 1, in other words, if we look at our CAST, sine A is positive, so therefore sine of A must be positive 5 on 13. We can do a similar idea for the cosine, or the B angle, sorry. So using the Pythag identity, that's sine squared B plus cos squared B. So as long as you sine squared and cos squared the same angle, it then equals to 1. We're told that sine of B is 7 on 25, so in other words, 7 on 25 squared plus cos squared B equals to 1. If you rearrange, cos squared B gets us 576 on 625. Square rooting, so cos of B is plus minus square root of those numbers gives you 24 over 25. And again, restrict our domain. So since our B angle is between pi on 2 and pi, in other words, in our CAST diagram, only sine is positive, so cos of B is negative. Therefore, cos of B is negative 24 over 25. And then so we can combine all that knowledge, because now that we have sine A cos A and sine B cos B, we can work out what sine of A minus B is. So using the equation or using the identity, copying from the formula sheet, sine of A minus B is sine A cos B, so this is the one we talked about today, minus cos A sine B. We can just substitute the values in. So sine A, we worked out was 5 on 13. Cos of B, we worked out was negative 24 on 25. Minus cos of A, we were given as 12 over 13, times sine of B, we were told in the question is 7 over 25. If you calculate all of that, that gets you 204 over 324.